All right, so now we're going to do a lesson that's very, very similar to 3-1. All right, it's kind of like the opposite of 3-1. How did 3-1 start? Do you remember the postulate and the theorems? What was the first phrase of that? It said, if what? If two parallel lines, right, are cut by, oops, forgot the I. If two parallel lines are cut by transversal ... Okay, then corresponding angles are equal, alternate interior are equal, exterior is equal, right? And then the consecutive interior angles are supplementary, right? So every one of those started off with this phrase, if two parallel lines, right? What we're going to do on this section, it doesn't say if two parallel lines. It just says this, watch. If two lines are cut by a transversal, I'll write that in there, are cut by a transversal. I'm not going to write this every single time, but I'll write it on the first one, okay? If two lines, it doesn't say they're parallel, does it? Okay, if you just have two random lines, all right, and they're both cut by transversal, okay, how do they say this? So that the corresponding angles are congruent, okay. I'll put and, let's just write how they write it. So, let's see. Yeah, they just say so corresponding angles, shorten that, corresponding angles are congruent or equal to each other. Okay, then, all right, that's a long if. So if you have two lines cut by transversal, and if you see that the corresponding angles are actually congruent to each other or equal to each other, guess what you could say about those two lines, those two random lines? What do you think they are now? They must be parallel, okay? If the corresponding angles are equal, then the lines are parallel. Then you have parallel lines. I'll say it like that. I'll write it like that, okay? Do you see the difference? Okay, the other one said, if you have two parallel lines, then what? The corresponding angles are equal to each other. This is a little different though, isn't it? This just says if you have two lines cut by transversal, and if you see that the corresponding angles are already equal to each other, if they tell you that one angle is 30, the other angle is 30, all right, then what could you say about those lines? They got to be parallel to each other, okay? So when I said earlier just two random lines, well, they're not just actually two random lines. So we're going to do this. Well, I'll tell you what, let's do two random lines. Let's do a line like this, okay? And then we have a transversal. So let's say this angle right there. So let's say that's angle 1. Let's say that's angle 2. What's true about angle 1 and angle 2? They are what kind of angles? They're corresponding angles to each other, okay? Now, if I told you that they're equal to each other, what must be true about these two lines? They're parallel. Does it look like these two lines are parallel? No. So what could you probably say about angle 1 and angle 2? They're not equal to each other, okay? But if those two angles were equal to each other, then that would force the lines to be what? Parallel, okay? So that's really the only thing different. So 1 and 2. So now, if I told you, now look, I didn't put that these lines are parallel, did I? I didn't put that little parallel symbol there, right? But I did tell you that angle 1 and angle 2 were equal to each other. That right there is enough to say that what's true about these two lines, then they are parallel. So if this is line L and this is line M, and they told you, a lot of times in geometry, they'll say given. Okay, this is the stuff that they tell you is true. So what's given here? What's given? Angle 1 is what? Equal to angle 2. And basically, we want to prove that these two lines are parallel. So if the two angles, if the corresponding angles, let's stop typing. If these two angles, corresponding angles, are equal to each other, then guess what's true about these? Then what? Line L is parallel, not equal, parallel to line M. Okay, then they're parallel to each other if angle 1 and angle 2 are equal. If I didn't know that angle 1 or angle 2 are equal, could I say that they're parallel from the information that I've given? No, okay? But if I know that 1 and 2 are equal, then those two lines are parallel. That goes for all the corresponding angles, right? If I knew that this top left one was equal to this top left one, then the lines are parallel. If I know that the top right and the top right are equal, lines are parallel. If I know the bottom right and bottom right are equal, then guess what? The lines are parallel. Thought you were playing along here, okay? They're parallel to each other. Everybody with me on that? Okay. So let's take a wild guess about those other angles. So let me, backspace. Okay, let me do this. Let me just write 1, 2, 3, 4, 5, 6, 7, and 8. So we know if the corresponding angles are equal, then the lines are parallel. Got it? What do you think the next thing that we could probably know is? If the... Come on, what did we learn yesterday? We did corresponding angles first. What was the next thing we did yesterday? The alternate interior angle. So what do you think might be true? What if I told you that angle 3 was equal to what? Angle 6. What if I told you that they were equal to each other? Then the lines would be parallel to each other. Are you following now? You get the... What is it? The... I forget words so easy anymore. It's so terrible. I didn't used to be like this. Like in the flow of things. What is it? The pattern. You see the pattern that's developing here. Yes? Okay, so if the corresponding angles, then the lines are parallel. If the alternate interior angles are equal to each other, guess what? The lines are, talk to me, parallel. Give me the next one. If the alternate exterior angles are equal to each other, what would be alternate exterior? Let's say 2 and 7. So if they told you that 2 and 7 were equal to each other, guess what? What could we say? That the lines are parallel. Everybody got it? Right? And we had one more. If the consecutive interior angles are not equal, but what? Supplementary. So I'll do this. All right? So if, we'll do this. If angle 4 plus angle 6 equals what? 180. Then, what's true? The lines are parallel. So line L would be parallel to line M. You with me on this? All right, so those are things that we know. If we don't know that the lines are parallel to begin with, we look to see what they tell you about some of these angles, right? That's kind of the basics. That's kind of like the ground level of this. Let's do an example, and I'll show you what they're really going to do with this, all right? And then I think we have another one to do, but let's do this first. So this is example 1. This is right after the corresponding angle thing, all right? So they got to, oops, copy and paste. A lot of times I just get in the habit of drawing parallel lines like this all the time, okay? Do parallel lines always have to be like horizontal like this? No, okay? They just, like right here, I copied and pasted, so they're both at the same exact angle, all right? So what if I put a transversal, like right there, okay? There's 2 lines cut by transversal. Do I know they're parallel? Or you're like, well, you just said you copied and pasted, so yeah, they got to be parallel. But if you just looked at this, right, you didn't know I copied and pasted it, could you tell that those 2 lines are parallel? Now, they look like they're parallel, don't they? All right? But you can't tell just yet. So what they're going to do is this. They're going to say, find the value of x that makes those 2 lines parallel to each other. I'll show you what I'm going to do. So let's extend this one. Let's just drop this one down a little bit. Okay, that looks a little bit better. Let's see, 6x minus 8 is this angle right here. That's 6x minus 8, that angle. All right, and then this angle over here is 4x plus 17. 4x plus 17 degrees. Put that in parentheses, put a little degrees out there. Okay. Now what you're going to do, now again, right now, you don't know that those 2 lines are parallel. But what we want to do is we want to find what value of x is going to make those 2 lines parallel to each other. You with me? So what does that mean? What does that mean about these 2 angles? Well, what are they, first of all? What's the relationship between those 2 angles? They're corresponding angles, aren't they? Everybody see that? Because look, this is the one that's over here on the right-hand side of this group of 4. This one here is over here on the right-hand side of this group of 4. So they're definitely corresponding with each other. So what did our postulate say? our postulate said if those two angles are equal to each other, then the lines are parallel. So we want to find what value of x is going to make those two things equal to each other. You got it? All right. So what do? Set them equal to each other. Exactly right. Okay. So 6x minus 8 equals 4x plus 17. So once we solve for x, if you put x in for this and that same value for this, it's going to make these two angles equal to each other. If those two angles are equal to each other, then the lines are parallel. Very good. Okay. Everybody awake? All right. It's second period. It's not first period. You know that, right? Okay. So let's solve for x. We've done a bunch of these already, but we'll do it again. So minus 4x from both sides. Minus 4x. You could bring everything down, but what do? I like to do them all in one step. So what's the next thing I'm going to do? Yeah, I'm going to add an 8 to both sides. Add an 8 to this. What's this? 2x. And that equals what? 25. Is that right? All right. And then we divide both sides by 2. And x is 25 over 2. They actually write it as a decimal. They write it both ways. So unless I specify, to tell you the truth, if I don't specify how to write that answer, I would just keep it like that. It's already reduced, isn't it? Because 2 doesn't go into 25 evenly. So it's already reduced. So I would keep it like that. Some of you guys might want to change it to a decimal. What would it be if it was a decimal? Can you do that in your head? 12.5 or 12.5, right? Okay. But I'm looking at this. I'm going to put that x back into this. Well, actually, we're finished. They don't even ask you to find the value, or they don't even ask you to find the angles. They just said, what is the value of x to make those two lines parallel to each other, right? So we're basically done, right? But if you wanted to, all right, we'll just do this. If you wanted to plug it back in and find out what that angle actually is, because they could ask that at some point, right? So let's just figure out what it is. So it's 6x. So it's 6. Now watch, this is why, now if you have a calculator, it'd be perfectly fine to go 12.5 times 6 and do the rest, all right? But let's say we didn't have a calculator on us. The easiest way is actually use this as a fraction. And a lot of people kind of stay away from fractions, like, if I don't have to do a fraction, I don't want to do a fraction. This actually makes it, I think, a little bit easier. So it's 6x, 6 times x. What is our x? It's 25 over what? 2, all right? And then what? Minus 8. Do you see why it's easy to do this? Especially since this is an even number right here, because 2 goes into 6 how many times? 3 times. 3 times 25 is 75. 75 minus 8 is, I don't know, what is that? 67? 67? So that would be 67 degrees, right? So what's this angle right here going to be? Without doing any math, 67 degrees, because they're equal to each other. Well, we set them equal to each other in order to make these two lines parallel to each other, okay? Now, you didn't have to do that. That was just fun. I don't know how fun it was, but anyway, that was just a little extra. So that's what they want right there. They just want that angle. They actually do. They do a check on this. I'm not going to make you do a check, but they do a check to see if these two angles actually are equal to each other. So let's do one more. Let's plug this back into this. So it's 4 times x, which is 25 over 2, plus 17. And what's this? This 2 goes into 4 2 times. 2 times 25 is 50, plus 17 is what? 67. Yep, they do equal the same exact thing. So we kind of checked it just to make sure we did everything right. But that's the answer right there. That's what they asked for. Okay? We good with that? Yeah. And they're going to do the same thing with the other ones. With the, they'll do it with alternate interior angles. They'll do it with alternate exterior angles. And they'll do it with consecutive interior angles. But what do you do with consecutive interior angles? You don't set them equal to each other. What do? You add them up and set them equal to 180. Right. Everybody good with that? Let's talk about this one. It's kind of the same thing. So I'm not going to draw pictures for the alternate interior, alternate exterior, and consecutive interior because we kind of talked about it already, and I think you get the idea with those. What if you had this? What if you had two lines cut by a transversal? Okay. and they told you this. Now, if they just told you that was a right angle, does that mean that this is a right angle right here? No. Now, yesterday, we said that the two lines are parallel, but today, we don't know if those lines are parallel or not. Would you agree? So just knowing that this is a right angle doesn't mean that this is a right angle right here. Because what if this is just like slightly slanted and you didn't even notice that it was slanted? Is this a right angle here? No. So just because it's a right angle here does not mean it's a right angle here. You got it? But what if they told you that it was a right angle? It was given, right? What if they told you that that was a right angle right there? Then these would be parallel to each other, okay? So we'll call this line A and B. So if these two angles are equal to each other, then what must be true about the two lines? A must be parallel to B. Make sense? And we can actually prove this. How do I know? Just because it's a right angle. Well, what's true about this one and this one from what we talked about before? What's the relationship between those two angles? They are what? Corresponding angles, right? So they are corresponding angles. And they're both 90, so they're both equal to each other. So if the corresponding angles are equal to each other, guess what? The lines are parallel. Make sense? Yeah, that's not too bad. I think they have one more. I didn't take notes on this. Sorry, so I'm going from the book. Not that it matters to you that much. All right, I guess we can do this one. This one's kind of weird, but this is called the transitive. Let's write it down. Transitive property. Transitive property of parallel lines. I'll just shorten it, parallel lines. That's why it's nice to know these symbols, because sometimes you don't have to write out the whole word. You can just put the little symbol there, all right? So it says, if two lines are parallel to the same line, so let's do this in a different color. Let's do like that. Okay, so here's a line. So if I have two lines that are parallel to this line, what do you think must be true about those other two lines? They got to be parallel to each other, correct? So look, if two lines are parallel, let's make this a different color. Let's make this white. All right, and then I'm going to copy and paste that and put that up here. If I can grab it, come on, there we go. If two lines, let's see how they say it again. If two lines are parallel to the same line, then they are parallel to each other. So watch. We're saying that this first white line is parallel to the pink line. The second one is parallel. So watch this. So if this one is parallel to this one, and this white one right here is parallel to the pink one, then guess what's true about these two right here? Then they got to be parallel to each other. Everybody see that? So if that has one arrow, because that has one arrow and they're parallel, then this top one and this bottom one are parallel, that must mean these other two are parallel. So that's what the transitive property of parallel lines says. We don't really use it all that often, but there you go. Yeah, I think that's good enough. I think we can stop there. All right. And let's see, your homework is what, 1 to 22? So it's section 3-2. It's page 116 and 117. Pages 116 and 117. Numbers 1 to 22. All right. Well, you got an extra long time to get that finished, don't you? Because you got the weekend, plus you got Monday and Tuesday. I'll be here Monday and Tuesday. On Monday, we're here till 8 o'clock. Somebody better turn off their phone. All right, so if you want to come visit me, feel free. I'll be here till 8 on Monday. Not all day, though. We don't come in till noon. But there you go. All right, everybody good with this? All right, have a good weekend.